Okay, this is Math 20-1 in Alberta, and this is Gavin's work. He's been working on factoring. And so here our first example, forgive the shaky camera. Our first example is an x squared plus 7x plus 12, and we've decided to treat it with algebra tiles, drawing first. In the middle of the screen you see his drawing. I've shown him on the bottom right of the screen where he might do a simplified version to save himself a bit of time. And in the bottom middle of the screen you see a grid version of the solution. And these kind of questions are usually easy for students. The A value is 1 and it doesn't seem to get complicated. So in this work I accelerate pretty quickly with my students to an A value not 1. And so Gavin basically threw down his two x squared terms and then began to experiment. The first thing he did as I watched him was he took the 12 and he made little dot arrays. We'll see them in another question actually. And he found which one of the dot arrays for 12 would fall into a place such that 11 x's would be needed. And so he chose that 8 and 3 combination, or 4 times 3, which then led to those this particular 8 and this 8 here. You can see how the quadrants, that's the 8x, match this quadrant of the grid, and this 3x matches this 3x in the grid, and our 12. Okay, here, another question. All positive things from, so far. Forgive my finger. So right here now you see where he's thinking about 6 as 2 times 3 or 1 times 6. And he right away realizes that this one is the one that's going to work because he can see it moving into place here and giving him a necessary 9x and a 2x, which would add to this 11x. Over into the grid, there's the 9 and the 6. There's the 3 times 3 is 9. Here's the visual. 3 times 3 is 9. And there's the x times 2, and here is the x times 2. So here's his factors written in a more traditional form. Next grouping has negative terms, so things get a little wonky. Now in his drawings he's not reflecting what negative is, that's okay, but in his grid he's figuring that out. So in this case he disregards that common factor right away. The red is my writing. So he disregards a common factor because he can factor this without worrying about that. So here we are, and he also has figured out, here's all of his arrays of that 18. Lovely demonstration of how to think about that. The one he chooses is this one in the bottom, and he tips it sideways and it makes the question work. So there you have that question. But in my writing I said, well, the 2 could come out if you want to. That would lead you down here. The 2 could come out at this point. And out of the drawing the 2 can come out because you see an even number all the way across this side. And so that would lead you to just writing 2 of these smaller squares, x minus 3 times x minus 3. I'm just going to go through the rest of them. You can pause at any time to look at these questions and see how this works. It's a guess and test idea, to be really honest with you. You throw down the 5x squared, and the only array possible, because 5 is prime, is that 1 by 5 array of the x squared pieces. Again, you can pause at any time. Here he listed all of the factors of 36. He knew that drawing 36 would be tiring, and so he chose to go with the grid only in this case. And then here, you may know this one is a difference of squares if you've been working with other kinds of methods, but this works exactly like everything else. You don't need a number of methods if you're using a grid method of factoring. You can simply treat this as an x squared piece, a bunch of negative 1 pieces, and you need to make sure that your x's cancel out. And the only way to do that is to make 2 groupings with the same value with different signs. We talk about this kind of a question being a really wonderful question for a visual approach because the numbers are small and they're fairly prime. 4 is not a prime number, but it's got primeness to it. There's only a couple of options to consider, so drawing that picture is pretty lovely. this one too, picture or grid. Again, pause whenever you feel like it. This one's tougher. So Gavin employed some other thinking here, and we'll talk about it in another video. In the meantime, testing out what are your possibilities for that x squared. Again, he went straight to the grid because drawing 100 squares would have been hard, and 58 also hard. And lastly, here. And here you notice he didn't even have to write in what would have been 6x and negative 9x in those two quadrants that are blank in the grid. The ones there and there. Because his thinking was getting pretty fast by this time. So that's grid multiplication. Actually, it's grid factoring, but grid multiplication works well too. In fact, with my students, I do grid factoring before I do multiplication. We learn it at the same time. Multiplication becomes quite an easy extension of factoring. What we're doing here mostly is saying, I know what the area of a shape is, so what are the dimensions of that shape? Thanks for listening.